My goodness, it is hot in here, but you'd be surprised by just how hot our neighbor Venus is. Venus, often referred to as Earth's opposite twin, has a similar size and composition to Earth. It's just 30% closer to the sun. This change in distance should account for around 90 degrees Fahrenheit change in temperature on the surfaces, but Venus is 800 degrees hotter than Earth. This was discovered back in the space race, and it led to a series of questions posed by scientists. So, why is Venus so hot? Turns out it's due to a runaway greenhouse effect, as its distance does justify the evaporation of all water, in turn releasing carbon deposits into the atmosphere which further trap heat in. This has led to temperatures that can melt lead on Venus. But here comes the next question, and one that stumped scientists since. How does Venus lose its heat? Scientists classify planets that generate heat as geologically active. Earth qualifies, and recent studies are suggesting that Venus does too. But every geologist will tell you that a planet that's constantly generating heat needs to lose it in some form. Scientists evolved two theories for how Venus loses heat, both of them based off of how we know the Earth to work. The first method is plate tectonics, the method in which the Earth uses. Cold parts of the Earth's crust subduct under the surface, and the heating of that chunk of Earth is how heat is released. Additionally, when plates rub together, magma escapes through the cracks, also losing the planet's heat. The second proposed idea is volcanism, such as Jupiter's moon Io, in which continually active volcanoes help lose the body's internal heat. So if Venus is almost exactly like Earth, it should lose heat the same way too, right? Wrong. Venus had no evidence of plate tectonics, and a closer look at the planet was necessary. The Magellan mission was then sent. Atop Venus, there were no active volcanoes found, nor was there any sign of plate tectonics. In fact, the planet was almost uniform in its surface, implying that the whole planet was the same age, 500 million years old. Scientists turned to two theories to explain this. The first was catastrophism, in which the entire lithosphere would cave in on itself and become a magma pool for centuries, where then the planet would slowly cool to form the Venus we know today, and this would happen after hundreds of millions of years. However, this goes against the fundamental geographic principles of uniformitarianism that explain that change is extremely slow, and we live on a planet that is not unique to our time frame at all. The second theory relies on uniformitarianism, and predicted that if Venus had an extremely thin lithosphere, it could slowly release heat into its atmosphere. To answer this question, Magellan plunged into the Venusian atmosphere to gain gravitational data, which reaped inconclusive. Magellan then plunged into the Venusian atmosphere after being unable to solve the debate, and for a very long time there was a lack of political will to keep trying. However, recently interest in Venus has resurfaced, and scientists think they might have evidence of plate tectonics on the planet. But these are all events that are unfolding today. So how does Venus, the hottest planet in our solar system, lose its heat? Hopefully we'll find out one day.